how are cyclones formed? To start off, you should know that cyclones, hurricanes, and typhoons are the same thing. They're all essentially the same weather phenomenon. The name just changes depending on where they occur. In the Atlantic and Northeast Pacific, we call them hurricanes. In the Northwest Pacific, they're typhoons. And in the South Pacific and Indian Ocean, you guessed it, cyclones. But no matter what you call them, these storms all have one thing in common. They're nature's way of throwing a massive temper tantrum. So, let's break down how these meteorological monsters come to life. It all starts with a perfect storm of conditions. Pun absolutely intended. First up, we need warm water. The ocean surface temperature needs to be at least 80 degrees Fahrenheit, but it's not enough for just the surface to be warm. This toasty layer needs to go deep, at least 150 feet down. Why? Well, because these storms are hungry beasts, and they need a lot of energy to keep going. Next, we need some atmospheric instability. Basically, the air just needs to cool down quickly as you go up in altitude. This temperature difference creates a kind of atmospheric escalator, allowing warm, moist air to rise rapidly. And we also need high humidity in the mid-atmosphere, about 16,000 feet up. This humid layer acts like a cozy blanket, helping to nurture our baby cyclone. Now, the location. Because cyclones are picky about where they form. They need to be at least 300 miles away from the equator. Why? Well, because they need the Coriolis effect to get spinning. This effect, caused by the Earth's rotation, is too weak near the equator to get our storm twirling. Lastly, we need relatively calm winds in the upper atmosphere. If the winds change too much with height, they'll tear our developing cyclone apart before it can really get going. So, we've got all our ingredients. Now, let's cook up a cyclone. It all begins with a disturbance. Maybe a cluster of thunderstorms or an area of low pressure. This disturbance starts to organize, drawing in warm, moist air from the ocean surface. As this air rises, it cools and condenses, forming clouds and releasing heat. This heat is like rocket fuel for our developing storm. It causes the air pressure at the center to drop even further, which in turn causes more air to rush in. And thanks to our friend the Coriolis effect, all this inflowing air starts to spin. As more warm, moist air feeds into the system, the process intensifies. The winds spin faster, more heat is released, the pressure drops further, and boom! We've got ourselves a full-fledged tropical cyclone. They're big and they pack a punch. On average, they're about 200 to 250 miles in diameter, but some can grow to monstrous sizes. The largest tropical cyclone on record, Super Typhoon Tip in 1979, had a diameter of 1,380 miles. That's like having a storm stretch from London to Moscow. But size isn't everything. What really matters is intensity. Meteorologists measure cyclone intensity using wind speed. A tropical storm becomes a cyclone, or hurricane or typhoon, when its winds reach 74 miles per hour. But they can get much, much stronger. The strongest winds ever recorded in a tropical cyclone were in Hurricane Patricia in 2015, which had peak winds of 215 miles per hour. That's faster than the top speed of many race cars. But how do these monsters keep going? Well, think of a cyclone like a giant heat engine. It sucks up warm, moist air from the ocean surface, which rises and releases heat as it condenses into clouds and rain. This heat further lowers the pressure at the center, which causes more air to rush in, and the cycle continues. As long as the cyclone stays over warm water and atmospheric conditions remain favorable, it could keep intensifying. But don't worry, these storms can't keep growing forever. Eventually, they'll encounter conditions that cause them to weaken. This could be cooler water, which cuts off their energy supply, or they might move over land, which not only cuts off their fuel, but also increases friction, slowing them down. Sometimes, a cyclone might encounter wind shear. That's when wind speeds or directions change dramatically with height. This can tilt or disrupt the cyclone's structure, weakening it. But sometimes, not fast enough. In 1970, we saw the deadliest cyclone yet, the Bola cyclone, which struck East Pakistan, now Bangladesh, killed an estimated 300,000 to 500,000 people. That's the immense destructive potential of these storms. But here's something fascinating. Not all parts of the world experience tropical cyclones. They tend to form in specific regions over warm tropical and subtropical oceans. The Northwest Pacific is the most active basin, followed by the South Indian Ocean and the North Atlantic. Some places, like the South Atlantic Ocean and the Eastern South Pacific, rarely see tropical cyclones, and if you live near the equator, you're safe. Tropical cyclones can't form there due to the weak Coriolis effect. So, what do you think? Are you fascinated by the power of tropical cyclones? Or maybe a little terrified? Drop your thoughts in the comments below. And if this sparked your curiosity, dive into our next video. You won't want to miss it.